This project which I am about to explain talks about a classification problem. Well, I'm going to start solving this problem using CREST-DM framework. Well, before moving ahead, CREST-DM framework components are as below, like business understanding, data understanding, data preparation, data modeling, model evaluation, and then finally model deployment or insights of it. Starting with business understanding, the problem at hand was a classic problem in the field of pattern recognition, which was recognition of handwritten digits. Data had been provided with pixel values of image of digits submitted by a user via a scanner or a tablet or any other digital devices. The goal was to develop a model that can accurately identify the digits between 0 to 9 written in an image. Well, coming to data understanding, if you look at the data, we understood that there were around 60,000 rows having 758 attributes, which were numeric. There were no duplicates and no missing values. As outliers do not impact SVM, we did not treat any outlier value. So the data looks clean and we can proceed with data preparation. SVM model works only with numerical attributes, so we had a check to make sure all the columns we have are numeric in nature. We come to the model building and evaluation. Now, before we move to build model, we need to understand why we choose SVM over other models. Given the data set having a large feature list with pixel values for each image and the goal as classification problem to identify 10 classes, we definitely rely on SVM rather than taking call based on probabilities as in logistic regression or homogeneity measure as in decision tree. Advantage of SVM over logistic is that we need not worry about the probability cutoff to identify the classes. Also, in this case, we do not need the path to arrive at a decision point, so we can use SVM in this case. SVM works by introducing a margin to separate different classes in linear space. A best fit margin is selected such that to maximize the distance between the closest point and margin. The boundary of margin is called the boundary of closest point of different classes forms the support vector classifier having support vector points. This margin is also called soft margin when the model allows few of the points to misclassify. This introduces an error or cost factor in the SVM equation. So this becomes a hyperparameter in SVM to control or limit the overfitting of model. The other hyperparameters is sigma, which decides the nonlinearity of the boundary in the space. SVM is a linear model but works well with nonlinear datasets. SVM converts the attribute space to multidimensional linear feature space. This is done using the kernel trick by taking the dot product of the attribute in the feature space. In this case, we took a sample of data from 60,000 and we built the model using vanilla dot or linear and RBF model. We then calculated the confusion matrix to evaluate the model. We found that using RBF dot or polynomial classification margin, we achieved the best accuracy. We then performed the 5-fold cross-validation using scaling the values and without scaling the values and applied radial SVM to understand if any combination of C or sigma in nonlinear space gives us a better accuracy as measure. We found that the accuracy was low with radial or nonlinear margin, so we considered the RBF model as the best fit margin. Using SVM model, we could predict the handwritten images up to 96% accuracy overall.